Today, today we continue with what we did as a part of the predictive analytics. So just to get to connect what we did in session one, session two to what we are doing today. So we in fact started off with the saying the the continuum of analytics typically is the descriptive, which is history. In fact, it's all the past data. So which normally we tend to do more often and in a visualized form. So if you recall, in the first session we said we should actually explore the data in the sense that every data tells a story. So what are some of the things you will do to see what the data is telling, what the story of this data, what are some of the things as an exploratory kind of analysis, what are some of the things you will do? I mentioned about it. In fact, we downloaded the data analytics tool and we said, hey, the Excel has an inbuilt data analytics tool and which helps us a lot. You can use this descriptive statistics where you can actually look at the data as to, first of all, hey, um, you know, uh, what kind of central tendency measures is it showing? What are some of the central tendency measures when we talk about central tendency? Mean, median, mode. These are all, you want to look at a mean. Hey, what is the day? What is the mean of this data? Median are all in a normal distribution curve, or are they positively skewed, or is it negatively skewed? You can actually do a histograph and get to know. Then you can also look at dispersion, the range of the data, right? And the skewness of the data, okay, the width of the data. So if and then do a scatter. We asked, right? You can do a scatter and see how the data is distributed. Does it show some kind of a pattern? You can do a trend line and see the direction. Okay. So we did all that. And thereafter we said, hey, then how do we link this HR analytics, what we are doing, to business goals? So we have to understand the business strategic drivers. If you recall, we talked about strategic drivers, how they can differentiate and create a kind of a competitive advantage. So once we know what are the business goals, what are their strategic drivers, then we can then link what we do to the business goals. So then it becomes what? Very impactful. Okay. Then having done that, we said, hey, then we also in analytics, we then uh, uh, in the continuum of or the maturity model of the analytics, we can look at advanced analytics. So when we talk about advanced analytics, what is that we are talking about? Predictive analytics. What is it? So when I said yesterday, when I say predictive, that means what? Forecasting. What? Telling what is that I need to do in the future, right? So looking at the historical data, past data, how can we predict outcomes? How can we predict decisions as to what is that we need to do? Predict and prescribe. And then yesterday we did one of the techniques called correlation. What happens when we are doing this? We are using this technique to see, hey, what are some of the variables we can see? If I'm increasing the competency level of my employees, can I see what? How does it impact? How does it impact? Shivashri? If I'm increasing the competency level of my employees, it impacts what?
The performance.
Performance. So can assume, but can I actually then check? Is there a correlation between, the competencies and with the increase of competencies, increase of performance? Okay, then what I will do, I can also then look at a regression saying, oh, Therefore, if I can increase number of hours of 3 hours of training, that means, the advanced analytics can actually state that if you increase so many hours, I can actually get so much of increase in performance. And that's what the regression does. We will show you how to do it. Okay. Or maybe we can look at what else. Typically, increase in what? If I'm going to increase the working conditions, is there an impact on what retention? If there is, then why not increase the working conditions so that I can actually increase the tenurity of my employees? Or look at attrition as, looking at, hey, what are those key factors which lead to attrition? So, can I then predict attrition? So, these are some of the advantages. So, if I say, if these are some of the advantages, does the organization really benefit or gain by doing these predictive models? Definitely, because in today's time, the organization like Amazon, Microsoft, Google, they are so much high on analytics that they take most of their HR decisions based on analytics. Okay. In fact, the data is among us that they use a lot of, you have today a lot of softwares which include algorithms, machine learning, and also AI. It becomes much easier. Okay. Though we are doing it in Excel, but it doesn't really matter. But if you have, because it is expensive. So if you have less data, it's okay. But if you have huge data like Amazon, etc., multi-location, huge number of workforce, then you will have to actually use some kind of a software. All right. So as I said, the advanced analytics, it helps you to make decisions. Like for example, if actually having a lot of items. So, when is a customer likely to exhaust their supply of an item? Even that you can actually make out. Or what time of the day or week are they most receptive to marketing advertisement? In fact, today, to increase their revenues, to increase their profits, do you know a lot of predictive analytics and modeling is around the customer, right? You are getting maximum information from the customer. In fact, you want to check, hey, what level of profitability is achievable when marketing is done at what time. These are some of the things which you actually can. So as I again reiterated, so you are using predictive modeling to take a decision which with the data around, so that you can actually get a outcome which is predictable. Okay. Like, for example, I talked about the competencies, I talked about attrition, I talked about what is it, working conditions, etc. Just to give you an example, saying that, okay, if your friend is going to ask you, is it going to rain? What will be some of those predictors? Obviously, if it is cloudy, right? Huh? Or the weather forecast. So you can't just say, Minadika, and say something out of just an assumption. Oh, it may rain, it may not. No, you will take some data into consideration. Then you will work out what is the probability of raining, right? Huh? So that's how predictive modeling helps you. So it also goes to say that when you're taking decisions, you can't really take decisions by just your gut feeling, because gut feeling does not back you up with data. Data is very, very important. Okay. So we did correlation yesterday, and we are going to do regression. And let me tell you, these predictive analytics are being used across industry and across all functions. Just to give you a little more, very interesting kind of example where, you know, when it, suppose, you are in the business of selling umbrellas, or winter jackets, and raincoats. So if there is 2 inches of rain, there will be some sale, right? But if there is much more rain, 4 inches of rain, then your sale will also increase. Can you see? Can you see my slide, guys? Huh? Just give me a thumbs up, okay? So, in fact, you can use so say for example, if you do a decision by gut feeling, oh, it's raining, so I'm going to stock up a lot of umbrellas and lot of raincoats, etc. Just because you know the gut feeling that is going to sell, and then it's not going to rain, then what happens to inventory? So regression, predictive modeling will take into consideration all this, the data points, the historical data, and will then predict, hey, you can buy so many, you can actually stock inventory of so many umbrellas. That's the beauty of a predictive modeling. Okay. Having said that, I want you all to pay attention now. When we did correlation yesterday exactly, what did we mean by correlation? Anybody who can give me a little lead? Did you? What did we do? When we said correlation, we said we looked at two variables and we said, is there a correlation amongst the two variables? Say, for example, I can say absenteeism and tenuity, or competency and performance, okay? Or number of trainings and performance, or experience with compensation. So we are only looking at what? Is there a kind of a relationship? Now, regression is different. Regression is different. What does it say, regression? This is again a statistical tool that predicts what. Now, there are two variables, but one we call it as an independent variable, and the other we call it as a dependent variable. Why? We'll say that in this two variables, one is the cause. That means it is it predicts the outcome. Predictor. So, like for example, in the selling of umbrellas, which is the independent variable? Rain and umbrellas. Huh?
The rain.
Rain is an independent variable. It will predict or it will cause. And which is the outcome or the response? It is the dependent variable umbrella, selling of umbrella. So now we are very clear. So IV, you can typically say as independent variable IV, dependent variable DV. Okay, be very clear. So here there are two variables. So the independent variable is always called X and the dependent variable is always called Y. Because when you plot data, your Excel understands that way. So you have to be very careful. If you do it reverse way, then your figures will be your calculation will all go wrong. Then, so as I said, regression analysis predicts the dependent variable, knowing the level of independent variable. So it is a predictive technique. While correlation only explains the relationship, it's an associative technique. Means, what is the association? How much is the association? If how do you measure correlation? From +1 through 0 to -1.
-1.
+1 through 0 to -1. Okay, so that's how you measure. Now, when we talk about, I will actually explain through the data also. When we are doing this, it's simple as, I don't know if you are done statistics, even if you ask a 7th or 8th class student, it actually, the concept is all about a straight line. You know, where we say if you have learned y is equal to mx plus b. Okay? Where x is the independent variable. Again, I'm re-emphasizing. Y is the dependent variable. All right? And I will explain to you these terms. M is the slope and B is the intercept. How do you do it? I'll explain to you. Now, so when you draw a line, yesterday also you have drawn the trend line. In regression, that line is called the line of best fit. What do we say? The line of best fit. Now, when is your data very good? When your data is very close to the line, fitting tighter to the line. Okay? when it is the distance is minimizing. But when it is very far away, when your data is very far away, then it's not a good line of best fit. Now that can be observed by this. This is the line of best fit when you do a regression. Your data should be very close. Okay. And if your data is far away, then it is not a good line of best fit visually. But as a measure, how can you make out? You can make out as a measure if the, yeah, first let me tell you, you know that R is represented as correlation coefficient. Yesterday we talked about it. And the regression is R square, which is also named as coefficient determination. Okay, coefficient determination. The closer the measure is towards 1, you can say it is very good. Just like in how do you measure here? Just like in correlation, we say from +1 through 0 to -1. Here the regression, the perfect regression is 1. So that means what? 0 to 1. So the closer you are to 1, that means you have a very good regression. The same thing I'm talking about. If it is tighter towards the line of best fit, what happens? It's a very good fit. Say, for example, your correlation is 0.9 and the two variables are, we did this some data, the CEO pay and the revenue. Now, in these two variables of data, which one will you call as independent variable X and which one will you call as dependent variable Y? Unmute yourself and anybody so that I know exactly. Anybody? Which one will you call? If you have two sets of data, one is your what? Revenue, and the other data is the CEO pay. You have done correlation also, and it is 0.9, which is very good, strong, positive correlation. Okay. Now, which is your independent variable and which is your dependent variable?
Revenue is dependent.
Revenue is the independent variable.
Absolutely. Higher the revenue, higher the CEO pay. Lesser the revenue, lesser the CEO pay. For example, when the two sets of data, CEO pay and revenue were done, both correlation and regression, the R was 0.9. That means strong positive correlation. And R square is equal to 0.81. Or you can also call it as 81%. What does it mean? I told you closer to the 1. That means the predictability is higher. So what does it say? That the variation of 81% of the CEO's pay is dependent on the revenue, which is very good. 10, 15, so the balance will be exactly what? Why 10, 15? The balance will be 19%. So that 19% will depend on his maybe qualification, some experience, some other things. Are you with me? 81% is dependent on the revenue. Okay. So here it is. No? So the 19% which is left, how is R square should be closer to 1, right? So now you still have 19%. That can be explained by what I told you, education, experience, other things. Okay. So R square is your regression and closer. So the perfect regression is 1, 0 to 1. So the closer you are to 1 is your good regression. Okay. All right. So like, for example, 0.1 to 1. So as you keep going, stronger the better. All right, let me actually show you an example and then you will understand better. Okay, I'll just work out an example for you, explaining the entire thing. I will take an interesting one. Yeah, I'll take a point plan because that is little interesting. Somebody said, how do we do? Okay, point plan. Okay, I will. Yeah. Can you see my slide first of all? Yeah. All of you, can you see? Okay.
Yeah.
Now, how can we use regression for what? We can use regression for many things. We can use it for manpower planning. We can use it, as I said, predicting what kind of training to be given. We can use it for attrition. We can use it for what is it? Early warning system, EWS. So here uh, we are using regression to predict salaries. Now, let me explain to you entire thing. So, typically, since all of you are in HR, and you should also understand that HR analytics is heavily used in compensation. Okay. Now, this particular thing, um, every organization, what happens, it wants to design their salaries with fairness and equitability. Why? If you are not designing salaries in fairness and equitability, there is a lot of dissatisfaction amongst the employees, which will impact performance and productivity. Having said that, what do I mean by fairness and equitability? For example, say Mitra joined an organization, say, for example, Amalgamate, that is, I think, Vijay, as an HR manager, okay, in a particular grade. Vijay also had joined the same organization uh, in the same grade, doing the same job, okay. But Mitra is hired at a very high salary because, she was working earlier in a very good company. And so, therefore, her last drawn salary and she got a hike of 25%. Now, Vijaya, she took a sabbatical for 2 years. But both of them are qualified with the right experience, having gone through the interview rounds very well. And the organizations found a fit for the job. But what happened? Vijaya has been offered much lesser salary. Now, the biggest joke is salary is confidential. Don't tell anybody your salary. Okay? But do you think salary is confidential? Once you're on the board, you would get to know, hey, how much are you getting? Huh? Obviously, no? No? Everybody will get to know who is getting what. Huh? Hey, but you see, I'm for the first one because you are on the without a job. Now you've got a job, you'll work. But after that, you will get demotivated because hey, that person is doing the same job, but that person is getting higher salary, but I'm not getting. So if supposing you are on a recruitment spree, you'll say, hey, that person is getting more. You can please take her. I'm not good. So you are lowering your productivity and performance. So, say for example, in an organization where there are 500 people or say 1,000 people, and 80% of the people are disengaged in work, it will result into lower performance, which will again impact your revenue and profits. But you are also paying certain percentage of wage cost, no, month on month, the guaranteed salary you are paying. So what happens? Your wage cost remaining the same, you are not getting your ROI. You are actually having disengaged employees because of these inequity and not being fair, and therefore is impacting your profits ultimately. So every organization will try to be pay their compensation philosophy will be to be fair and equitable internally. Just mark my words. I said fair and equitable internally. When I said internally, that means within the organization, There are several roles and there are several employees working in those roles and positions. Okay. So how you pay them internally, you have to be fair and equitable. You can't pay somebody more, somebody less. You have to pay by their worth of the job. Are you with me? You have to pay by the worth of the job, not by the title of the job. Having said that, they also have to be externally competitive. That means you have to ensure that how you pay internally, a equitable and fair, and externally competitive. Now, how do organizations remain to be externally competitive and internally equitable and fair? To be externally competitive, they are continuously looking at salary surveys and looking at the survey data and seeing, hey, where are we vis-a-vis market? Very clear? Just give me a thumbs up. This is clear. Where are we vis-a-vis the market? And that's where that word percentile comes, vis-a-vis the market. Okay? Now, having said that, internally, how will you do? You will actually do something called a technique called job evaluation. That means you are evaluating the job. All right. Now, job evaluation is different from job analysis. Are two different things. Okay. When you do job evaluation, what is job evaluation? You are analyzing the job. What does this job do? You are analyzing the job through questionnaires, observation, all those techniques. But ultimately, what do? You are analyzing what does it do, what kind of duties it has, what are the key responsibilities, etc., etc. So that you can create a job document, which is also called job description. Okay. So in organizations, you'll have a job description. That means the job will, why does this job exist or why does this position exist? What is the key, function of what is it supposed to be doing? In the sense, what is the outcome of this job? Then how is it supposed to be doing? What are the various things? What are the resources, material, training? Everything is given there. So now I take this document and then I will evaluate the job for the worth of the job in the sense, hey, this job, it has what? The requirement of knowledge, requirement of skills, and then the responsibility. Okay. Then the effort. It could be technical skills. Okay. It could be also physical, mental. So the nature of the job. So I'm not evaluating person. When I'm interviewing the person for a job, I'm interviewing the person. But here, when I'm evaluating the job. Anybody can come and occupy. Mitra can be there, Vijaya can be there. But I will take the job description and evaluate the job. And that's how I will assign points. This is a point method of compensable factors. Okay. If you can see my, earlier one, where I have said, hey, know-how, work experience, span of control, assigning points for all the positions. Just to give you a little understanding. Is that good enough? So for every job, then I will take a job description and say, hey, know-how, might be it needs degree 1. What are the points? 25. But work experience, maybe I need 2 to 5 years. So what are the points? 50. Span of control, maybe it's an individual contributor. Then what are the points? 20. Then for creativity, maybe it needs high creativity. I'll give 60. So that's how I'll add up all that. And that's how I have arrived at points. Is it very clear, guys? I needed to give you a little, otherwise it will sound like, hey, what is this point value? So this point value is a quantification number by which I will understand that this is the worth of the job. Clear? Okay. Now for our analytics where we are going to, let me explain now. Now here, say for example, in this organization, there are how many positions? 10 positions. There could be many positions, right? But I've taken here just a sample, 10 positions. So I have done what? Job evaluation through point plan. And I have arrived at the worth of the job in point value. So the positions are what? 220 points. So I can easily now say, hey, the highest job is here. Highest job is technical chief. Thereafter, HR manager. So I can put them, I have not put them here. I can put them in an ascending or a, typically you should do ascending or a descending order. Okay. But when you are doing ascending or descending order, now this will be a what? Independent variable or a dependent variable? It is independent of the job, no? The worth of the job will be dependent on the job description. So it's a independent variable. So what will you name it as? X variable. You will name it as X variable. Now I will get market data for this job HR team lead based on the job description and similar organization. What is the market paying? So what am I trying to do here? I'm actually now trying, because I want to pay a salary which is externally competitive and internally equitable. And I have already calculated the job worth so that I can pay accordingly. And I'm getting the market salary for competitiveness. Now I will use regression, predict internally what I should pay. Because when I'm doing regression, it takes care of both the X variable and the Y variable, and it will throw up the pay salary. Got it? What I need to pay internally. Now I'm using what? A predictive model called regression. How do I do that? Okay. Now you know that this is X. So I'm just going to do. So now we are coming to that regression. X, this is Y. Please raise your hand or tell me, hey, I need clarification here. Now, when I'm actually using this to calculate for any regression, I will calculate two values. What are those two values? Which I said, mx plus, you can say b, but because you will forget what is mxb, I put it simply. So to calculate the salary y, slope multiplied by point value. Point is that X point value. In this data, because it is job evaluation, we are having a point value. Another place you can have what rain data, okay? Point value plus intercept. Okay. So typically if you say the formula for a straight line, y equals to mx plus b. Okay, where x is what? Slope. All right. B is what? Intercept. M is x is the point value. M is the slope and B is the intercept. Is that clear, guys? Okay. Now, how to calculate slope? How will you do? Quick formula, right? Then this I have to actually. Okay. So insert function, then slope, right? Then, okay. So it is asking me for known y's and known x's. That's why it's very, very important. As I told you, otherwise it can come differently. So known y's will be my market salary. Done. Known x's. Now you will see that I have point plan for one position. Purposely I've left because I want to show you that with the help of regression, now some organizations will have unique positions and I can't get market data. They're unique to that company, unique to that product. So I'm not able to get market data. Then how will I compute or how will I fix the salary? So using this regression, I don't have to have a market data. I can actually calculate this, and then using the slope and intercept, I can calculate the salary. So just see how I'm going to do this. Sorry. Let me just Okay. Now I'll say so what is the slope value? 413. So what I will do is I can actually make it, sorry. Right here. Can I make it as 413.6? Okay. I can do it. 413 point, just for convenience, so that it becomes easy for us. Huh? All right. Okay. Now let us plot intercept value. Let me do it here then. Huh? So what will I do here? Insert function. So intercept. Okay. Known wise. Known axis. Then, okay. So what is it? Minus 64426.4, 6 and 7. So I can make it as minus 64426.47. Okay. Enter. All right. Okay. Now, so what is this? This is the intercept. This is the intercept. Now, how do I calculate salaries? There is the formula. No? What is the formula? Slope multiplied by point value plus intercept. So if you look at, what did I do? Just look at the formula. What did I do? Can you see here? Slope value is 414 multiplied by, because the point value keeps changing, I put there, okay, as that C18, then minus 64426 or 2. I just took the whole number. Now all that you need to do is put that, and then you get a number, and then if you drag it, you will get this. Very clear? Now, you must be wondering, even for this position also I have got it. Why? I don't need the market data now. I only need point value, because I have already calculated for a sample the slope and the intercept value. Got it? So I have used regression to predict my salary. Now this salary is externally competitive. How? Because I've taken external market data, and internally also fair and equitable. How? Because I've taken the job evaluation, calculated the job worth by establishing point values. So in most of the organizations, when you have to design salaries, you do this exercise. And when you have new positions which are unique to that industry, unique to that company, and you can't find market data, so you don't have to fret. 5%, 10% jobs will be unique. So you can still do that by using the market salary and doing the regression. So regression helps you to do that. So now let me also help you in okay, let me just delete this one. Now you can also select, right? Insert. Now we want to see R square, right? We are using the data, but we want to see the regression. So how to calculate regression? Insert. Then what will we do? Chart. Now what will I do? Click, add a trend line. Now there's another window opening up. What will I do here? Just see this, what I'm doing. Display equation on the chart, display R square value. Now, have you got the same slope value 413.57? You want to check that? Did you get that value? Same value? And what is your intercept value? Can you see that? Huh?
Yeah.
What is your R square value? R square?
0.9.
0.99. That means 99%. That means it is so closer to 1. Can
Yeah.
you see the data points almost on the best fit line? Just change any data, you will see that R square will be different. Like for example, if I change, let me see it. I will change this one. Okay. Into, say for example, I'll put just 50. Enter. Has it changed?
Yeah. 7.
Huh?
Yeah,
Because
but
there is an outlier. You are saying that job work is almost 385, but
no.
You are paying less salary. The position is far away from the line, best fit line. Like for example, just see this. If I put it as now, I can have a situation like this, and then I will say, okay, R square is 0.748, which is typically when you want to use this market data, and then typically you should look at R square and say, hey, anything above 0.80, that means 80% and above is a good R square. It may have a correlation, but if your R square is not above 80%, then you really can't then go ahead. Or you should go back to the drawing board and see, hey, like for example, I think Intel. So they don't go by job worth. They go by purely market data. Yesterday, Mitra was asking, why, ma'am, can't we do just by market data? Yes, there are certain organizations which will purely go by, if X position, I will find out what is the market data, and I will say, hey, do I want to pay above the market, which is called a lead, or should I pay a little lesser than the market, depending on the supply and the demand and the criticality of that position. Okay, so it may not have the worth because it's a very critical position and the demand for it is very high, but the supply is not there. So probably I have to pay as per the market. So, like for example, this job I'm paying, say for example, in reality, there is a job like this in the company who's paying like this, though through job evaluation. So we need to go back. Has the job evaluation done properly? That you are paying this much, but you have given high. So I have to go back to the drawing board. Are you with me, guys? Now I'll tell you another trick. Now you can also use what I call as data analytics tool for regression. Okay. I have to download it. Is it there? Let's cut. Okay. Now go to data analysis sheet. Now, can you then look for, as I said, data analytics has everything, right from a mean, median, everything it has. So look for regression. Can you see, can you spot regression here? Okay. Now a window has opened. So input Y range. So what do I need to do? Input Y range. Can you see, guys? I hope you all are able to see. Okay. So what will I do? Somebody guide me. Let me see. Input Y range. So what will I do? Click and
D18 to.
pardon?
Yeah, D18 to D25.
Correct? Huh? Okay. Input X range.
C 18 to 26.
Okay. Now, typically you want labels. Okay. Then confidence level is always 95%. Output range, do you want it in a new worksheet? All right. And you can have residuals, standard residuals, and normal probability. Line fit plot if you want. Okay. All right. And then say, okay. All right. 1 second. Now, can you see this output data? Okay. Now, typically, a lot of people who do a lot of research will need this output data. But for our purposes, right now, even when I'm doing a salary for predicting salaries, etc., for me, this, why 76? Because I changed the data, if you recall, right? So R square, this data is, for me, good enough. Okay. This is your regression, R square. And multiple regression if you have more variables if you are looking at. Okay. Observations are how many? How many? 7. We have 7 positions. All right. And you look at this and then you look at your intercept here. Okay. And then you have your slope here. So your intercept is here and your slope value is here and your R square is here. This is one way of doing your regression. There's one more way of doing regression, which is called a quick layout. So that's far more easier to do. You don't have to calculate slope, intercept, etc. And so I told you 3 methods of doing your regression. Okay. Now I want you all to do, you have data of salary. Don't get into data analytics output, because as of now, I want you all to do just either quick layout or using the, trend line. Okay. Um, I want you all to, how many of us are there? 9. So, guys, do you want to do it in one group or 2 groups? I think 2 groups will be better. Huh? In the meanwhile, can you locate? You have a regression called point plan, guys. And if any clarifications required, please check out. Ask me now.
But
Okay.
we
Now,
forgot the formula to calculate the regression actually. We have done here in the chat.
no problem. But then if you see here, your intercept and slope value also will reflect here, right?
Yes,
Can you
it
see
is
that?
one and the same. Yes.
246.34, that is
Mhm.
X actually, point value, minus 1905. Now your regression, R square is 0.96. That means 96%. The variation of the salary is 96% dependent on point value. That means just 4%. So it's so close that if you see your points, job points, they're so close and tied to the your
Line.
salary. Salary. We always call it as best fit line. Okay.
Yeah.
Yeah. This is good. Okay. Now this increase is simple because you just have to increase it by 15%. Okay. Now if you see if you can delete your R square, this one, you can also do it in another way, that quick layout. That means you just delete that.
Delete.
Delete
chart.
your this form, delete the chart. Let's just do it once again, and I wanted to show you that. Okay, now select the data. Yeah, select and then insert. Yeah, do that normal thing, insert, and okay. Now, when you click on the job, any job point, yeah, you get a quick layout. Can you see next to change of colors? on your header under home. Can you see under home?
Yeah.
Now do this FX. Can you see one FX as you go down? Go now to the other side layout. I think it is that one. Got it?
Yeah.
So you can use this method also. This is the other way to check. Is it reflecting the same value for slope and intercept?
Yes.
Yeah. Okay. Now I'll give you a challenge. So there is another unique position which has about 350 point value. Okay. Would you be in a position to calculate his salary to be paid?
Yes.
Yes. How will you do it?
The same thing.
Why? You know the slope value, you know the
Yes.
intercept value. So now all that you need to do is now add that, multiply it by a point value, right? So can I go to the other group, guys?
Yes, we got
Yes.
it. It is somewhere around 67,200.
Yeah. So I'm leaving the room. So good. And I'm just going to, I will explain to that. I will explain you that why market is showing so much and sometimes it is showing less or more. I will tell you. One second.
Yeah.
I'll tell you right away. So here actually is 2,000, 25,000, but here it is reflecting a little more. But if you have larger data, sometimes what happens, you might get less salary as in compared to market. You know what is happening when you're using a regression? It is not job to job. To establish fairness and equity in the way you are paying, it is taking into consideration all the jobs and their market data and then throwing up the salary. Got it?
Yeah.
Okay. Yeah. So sometimes you may have to go back and just see whether you have actually given sometimes what happens when you're doing job evaluation, accuracy is very important. So when you're evaluating a job, there is a possibility sometimes, to give more point value. Okay. But when you take the job description, see, you have done your point value. But say, for example, you have taken a program manager, you have done job evaluation and you've given 180 points. But you have taken the JD, what he is doing, and gone to the market. And you are taking market data. So sometimes market data could be as per the market. It could be less, it could be more compared to your salary. Got it?
Yeah.
Okay, let me quickly go to the other.
Sure.
Yeah, good guys. So I would recommend all of you to do this is done collectively, but if you have done it even individually there on your laptop, it will be there as a record. Now just go to quick layout. Okay, you know that already. Go to the quick layout, which is under home. Can you see? Under the home, you can see quick layout.
Yeah.
Click on that. Quick layout. You go to this FX. FX means 1, 2, 3. Third row
This.
to the end. One.
Okay.
Okay. Now see, is it tallying with your slope?
Yes. Now it is coming.
Is it?
Yeah.
Is it? So you can check sometimes. Right?
Yeah.
And even if you do this display equation on chart display R square, you will get the same thing. Okay?
Okay.
Got it?
Yeah. Understood.
Okay.
Then
Now you keep this to one side. Okay. Now you know how to do a graph. All right. Now proposed salary. Now you have to use this slope multiplied by, I'll tell you, hang on. Slope multiplied by point value plus intercept. Okay. Now what will you do? You know the slope value, which is, no, don't put your cell number. You know the value which is not changing, constant. So I would recommend put the value itself.
246
Equal to 246.34.
Yeah.
Now what you do, put your cell number and put a dollar sign and put a cell number. Point
multiplier
value.
should not be there. It should be there. Right?
Yeah. Obviously, you have to multiply, with the point value. So instead of the point value 115, you put your cell number. No, not the dollar sign. You just put the star and then put the this one. Now, because it is minus, you will do minus.
Yeah,
Put
okay.
minus
Huh.
and put the value because it's constant.
Okay.
19014.8.
Yeah.
Okay. Now you drag.
Yeah.
Got it?
Yeah.
So this is your proposed salary. Okay. And if you want to do 15% raise, which is very easy, I'm sure you know about. No?
This into 1.15? No.
I
No.
mean, yeah. I
0.15.
mean, see, for 100, you are increasing 15 rupees. So for 10464.
Yeah. So no, my
This is
question
simply
is,
na 10464. If you want 0.3, you can keep other no. Multiplied by 15 divided by 100, no?
yeah. No, in that
15%.
function we can directly do 0.15. No, that
Yeah,
that will
yeah. Oh,
work.
yeah, absolutely. I'm so
Ah,
sorry. I
yeah.
didn't hear that. Yeah, absolutely. 0.15. Yeah.
That was my question.
And drag it. That's it. Good. Great.
Yeah.
Okay. So now have you learned how to do this? And say, for example, I'm going to give you a position which is 350 points. Okay. This is a unique position and you couldn't find market data. Now, can you predict salary? You haven't got the market data for it. But can you now predict salary or can you now design the salary for that position?
Without having the market value?
Yes. Yes, you can do because now you don't need the market value because most of the organizations, they may have 80 positions in the market, but there are some positions which are unique to that organization.
Yeah.
You may not find market data. So how do they do them? Then compensation consultant, you have the slope value, you have the intercept value. So if you see the formula, all that you need is slope value and intercept value. And you can now multiply slope into that 350 points minus that value and you will get the position. Got it?
Yes.
So do that 350. If you have to do a position for 350,
Where? Come again?
I'm giving you a position for 350 where I have not put, there is no market data for it. But you
Okay.
have to now fix salary.
Fixes salary.
So simple.
Yeah. So yeah.
You can do
240
it independently. Yeah.
into
You can
3.
do it independently. So what you do is
Huh.
slope multiplied by, now
3.
you know 350
Huh.
minus
Minus 190.
19014.8 if you
Yeah.
want to keep. That's it.
Yeah. I'll just,
Enter. And what is the value? Correct. That's it.
yeah.
So don't put it there. When you go back, you'll wonder from where did this arrive? No? Put it under this proposed salary. 67204 and then put 300 points here. Or I don't know how many points, I forgot now. Did I give 300? 350. Good. Good job, guys. Where are the others? I hope everybody is here. Yeah. So you want to see the other group also they have done. So yeah, who is sharing the screen from the other group? Pallavi? Yeah. Anybody, whoever wants to. No.
Okay, I'm sharing it.
Yes, Vijay.
So we calculated the slope
Excellent.
with the
Yeah.
formula, intercept,
Yeah.
and then we calculated the salaries to be paid,
Using the
15%
formula.
hike,
Right.
and the total increased salary.
15%. Right.
Yeah.
Right. Yeah.
And we
then
also did the
can
chart.
you show me the graph
Yeah, one.
chart?
Okay. Having some trouble with my laptop today.
No
I'm
problem.
sorry.
No problem. I can see at least the equation here. So can you see your R square and can you see that you can also calculate your slope and intercept this way, right?
Yeah.
And also the quick layout. If you have actually noticed the other group, I was trying to tell them how to do it. Quick layout. Oh, I think I've told you also.
Yes. It
Yeah.
was told to us.
Yeah. So I hope everybody's here. So now you know using regression, how I can use in compensation to predict what? Salaries. And in fact, all the, uh, what is it? Deloitte, Mercer, then Eon Hewitt, they make huge amount of money by doing job evaluation exercise, getting salary survey, and they use regression to calculate salaries. Okay, guys? So what you have actually done is using a regression, a statistical technique, you've been able to use in the compensation by predicting the salary, right? By calculating slope and intercept. Now, what is the slope and intercept? So you looked at how many variables when you were doing regression? Anybody? I want little interaction so that I'm very sure that you're understanding. We looked at two variables in that. What are those variables?
Dependent and the
Pardon?
Dependent
Yeah,
and
Vijaya. We looked at
dependent
point
and
values.
yeah.
Point values as X data and market data as Y. So this is understood. This is point value, huh? And this is market data, if you can see. Now, when we inserted a chart and wanting to do a visual graph of it, we did a best fit line, right? With the data all here. So these are all best fit lines, A, B, C. There are three best fit lines here, okay? Now, what is the slope? I'll use pen, I think, okay? So for example, if I were to draw the slope, okay? Now for this, tell me just by looking at it, which best fit line will have a higher value for the slope? You can see visually here, which best fit line will have a higher value for the slope? Can you see that this will be the lowest, then this, then this. That is, C will have the lowest value, is almost like parallel. B will have higher than the C, and A will have higher than the B. So in essence, if I were to say what is a slope, it is the change, you can say the change in value of dependent variable, dv. I will just write dv here, dv, for every unit of increase in IV, independent variable. Can you see that? For every increase in this, it is the change in the dependent variable. Is it clear, guys, now? Huh? It is the gradient in this is the gradient. Now you may ask, what is intercept? Intercept is the intersection of this best fit line. Okay. Say, for example, this starts with zero. Okay. Now, what is intercept? Intercept is when The independent, I will just write IV, independent value is 0, 0. What is the value of DV, dependent variable, where the line of best fit is cutting, intercepting? Is intercepting. Any questions on this understanding, guys? Huh? But this value is calculated through statistical way. Excel is calculating for you, computing that. Got it? Okay. Any clarification? So slope is what? That for every unit of increase in the independent variable, which is the point value here, what is the change in the dependent variable? Okay, in Y. And then what is intercept? This best line of fit, where it is intercepting, cutting here, this point. So when your point value is 0, what is the value of that? Got it? Okay, can we move on? Now that you have understood slope and intercept, I'm closing this. No, I'll use this here. Okay. Where is that rubber? That's why the new system. Delete. Okay. 1 second, guys. Can't select. Okay. I'll use now. All right. Now, so there are a couple of other things in compensation where we can use analytics. Like yesterday, I mentioned about comp ratio. Anybody remembers? Comp ratio, very, very critical. If people are doing salaries and all that, even as an head HR, you recall comp ratio? Yeah. So comp ratio, anybody recalls the definition what I said? It is the ratio of your salary, which is a base salary, vis-a-vis the midpoint. How far are you from the midpoint? Okay. And why do organizations calculate this? Comp ratios can be calculated at an individual level to determine, like I gave an example, if somebody is come at a low salary, okay, and I have hired for a same job at a high salary. Now, two people working in the same job, but with differential salaries, right? Now, at the end of the year, I have a rating of 4, and even the other person has a rating of 4. That means both the people have done equally good. Now, because the person is at a higher salary and I'm allocating a certain amount of percentage of increment, that means that person will get higher increment. But what I will do is, as an head HR, to ensure that there is equity and fairness, based on the comp ratio, I will assign or accord lower percentage of increment to the person who is at a higher base and higher percentage of increment to the person who's at a lower comp ratio, so that I can bring this person closer to this. Because sometimes this is called salary compression. This is a word which is called salary compression. What is the salary compression means? Typically what happens, it happens in these organizations where when they hire people, they do not have any salary structure. Also, they do not do any job evaluation and pay them by, as they like. After some time, they realize that, there is no fairness, and they are paying high salaries to some people, and for the same job, they are paying low salaries. Now, how do they then? Because they also don't do market corrections. So, salary compression means paying lesser salaries to people for the same job where you are paying higher salaries. So, during annual increment, what happens then? Organizations decide, hey, we need to do something about the salaries. Then they start doing calculating all comp ratios. And then when they're doing the annual increment, they will try to, if two individuals doing the same job, but with a different comp ratios, they will assign higher increment to the person who's at a lower comp and give a lesser increment to the person who is at a higher comp. So you'll typically find, as a head HR, you'll have this problem. I got a rating of 5, but then my increment seemed to be lesser than that person who's also got an increment rating of 5. Why should it be? So, the business guy will say, I don't know what the HR has done. They will typically push it out to the HR department. And the HR is left to, clarify, respond, etc. It's very, very important to be transparent, because if you are not transparent, then there will be disengagement amongst people. You understand, guys, comp ratio, how we can use analytics here? Then, as I said, you can also look at computing market percentiles, right? Huh? Yesterday, we talked about market percentile. So what is market percentile? So when I'm taking any salary survey data set, so where do I stand in that data set? And in terms of analytics, how is it computed? In terms of percentiles. Now, data analytics tool, you have a data analytics tool, right? Oh, raise a hand. Neha, yes, Neha. You have Neha, you raised a hand.
Yes, ma'am. Actually, I just wanted to share that this time. So actually, the composition of the workforce that I look into also has some third-party employees, and
Yeah.
there is actually an upper limit set with respect to the CTCs that we can give out to them. Now we have some third-party employees who, even on contractual basis, have been there with us for very many years. So this and we had been giving them a normal increment year on year, but this time what we realized is that there are a couple of them who were actually reaching the salary limit, very close to the upper salary limit that has been defined for them. And so this time we had to actually do the salary compression for them, so that they do not go beyond the limit. And we are also able to be fair and bridge the gap between the third party employees who are actually in at higher salary ranges, and with same experience but at lower salary ranges.
Mm.
Just wanted to share that, ma'am.
Yeah. Also, typically what happens is, why it is very, very important that when you are recruiting, when you are hiring, okay, when you are hiring, you have to be that's why it's very, very important to have, first of all, salary structures. And then, say, for example, I'll just give a date. And then if you have, you know, um, if you have salary grades, especially the recruiting managers and the hiring managers, when you are fixing salaries, have to take the advice of the compensation person to ensure that the right kind of fitment has been made. With, say, for example, this is the min. I'll just, since you have brought that up, min. Okay. And yeah. Oh my God. This is the max. All right. And with the midpoint of the midpoint will be 10,000. This will be easier. Okay. So what happens specially? So when you're hiring, if you're hiring a person at 8,000 and giving an increment of 1,000 rupees, so that means you will hire either at 8,000, which is the min, or 9,000, or maximum 10,000. But if you go beyond that, that means you are actually hiring that person at a higher comp ratio. Say, for example, I've hired this person at 11. Oh God. I've hired this one person at a 11. Okay. Now, even on the contract, what we're referring to. So I give an increment of 1,000 rupees and he has reached this maximum of 12,000. Now I can't give it the next year another increment of and make the range extend to 13,000. I have to be, in most of the disorganized where they don't follow salary structure, they might be extending that. You can't do that. So once you have come to the max, then that person does not get an increment because the increment gets added on to the base salary for the next year. Got it? So, but then he'll be demotivated if you don't give him anything. So what typically is advised is, based on the rating, you give him a performance bonus year on year, but his base salary doesn't increase. But typically people in organizations, we don't let people stagnate in that grade for more than maybe 2 years or 3 years. Then they will try to, because maybe, there is no opportunity for promotion. And if there is no opportunity for promotion, they will try to offer a lateral position where maybe with an upskilling of couple of skills, probably, then they can, then they can again get into another grade and start getting increments. Okay. Yes, Neha? Yeah?
Yes, ma'am. Got your point.
Yeah. Okay. Close whiteboard. So, in fact, the maximum number of analytics is normally used in what? Compensation. Now, there's one more compensation metric we typically use, especially at a compensation level. What is that? I think I made a reference about it yesterday, I guess. That is, we said ECR ratio. ECR ratio. What is E?
Employee contribution rate.
Employee ECR.
Employee contribution rate.
No. So here it's a quantified number. So when we talk about ECR ratio, it is employee count to revenue. Okay. So how do you arrive at the ECR ratio? That is, you need to know the revenue of the company. Okay. And you need to know the employee cost. That is, from where will you get? You will get it from the payroll also. No? The employee cost per annum. Now, typically, how do you benchmark? As I said yesterday, most of the organizations will look at, hey, what is my ECR ratio? Is it 15%? Is it 20%? Is it 30%? Most of the service-oriented or the IT organizations will have an ECR ratio, employee cost to revenue ratio, as say 40%. It could be as high as even 40%. Okay. And manufacturing organizations will have something like maybe about 15 to 18%. Because here even 0.5% of increase will make a huge difference in terms of profits. Because to having in today's times, market is so competitive. So therefore, if you increase your wage cost, obviously your profits will be reduced. Now you can't increase the product cost or the service cost. Because in the competition, your competitors might be giving it for much at a much competitive cost. So to remain competitive, you have to benchmark, hey, what is your wage cost, that is ECR ratio, vis-a-vis the others. Now, initially, what happens when you are budgeting also, every year, you have to look at your competitors' ECR ratio. How will you go about if to get this data? Any clue? How will you go about getting this data? So, if you are a compensation person in the organization, or if you are an HR generalist, how will you go about getting this data? A, you have to identify at least 4 to 5 companies who are your competitors. Okay. B, then the listed companies, they will have something like annual returns, right? Huh? So, in your annual returns, you will find the revenue. In the profit loss statement, you will find the wage cost. So you can actually then compute the ECR ratio for those respective companies and compare it with yours. Is that clear, guys? So what another metric we typically track is your ECR ratio, besides the comp ratio, besides the market percentile, etc. Okay, clear? These are some of those key metrics in compensation. Okay, having said that, you have a very interesting data. I think this is the data, screen share.
Ma'am, I had a question.
Yeah, tell
Yeah,
me.
yeah.
Ah,
So, ma'am,
one
you
second,
mentioned
I
that.
will just stop sharing at that. Yeah, tell me.
So, ma'am, you were mentioning that ECR ratio we can also use if in case of a benchmarking exercise, we can take the data from competitors, and we can compare. So, just to hopefully I've understood it correctly. So, if in case I take this data and let's say my competitors have a higher ECR ratio, and mine compared to theirs is less.
So
So,
typically, Neha, this is what happens typically is at the beginning, of the year. So, in fact, it is at the close end of the year. The CEO will say, "Hey, if you were the HR head, they will ask you, hey, what is your, compensation budget for next year, right?"
mhm,
So if they were to ask you, then you will have to give him a budget figure. So there are two ways of looking at it. One is you can look at your historical data, what was last year, your budget, and then look at your target revenue for this year.
yeah.
So last year's revenue, that was what you actually spent. But now this year, say if they want to grow by 25% or 30%, obviously your budget has to increase by that much amount. No?
Hmm.
Because you will be hiring people, maybe there will be new changes, maybe there will be some kind of other. So you have to then keep a buffer. So typically how you forecast is you look at what are the figures, what is the business goal in terms of figures, what are the revenue figures. So based on that, then you will start calculating the budget. If it is 25% growth, then typically based on your last year's expenditure, you will then say, hey, so obviously I'll have to increase it by 25% or so. But even then, once you have actually concluded, then your CEO will again discuss and reduce it by some amount. No, that's one way. Then the other way which you are talking about is, yes, you are a startup. You don't know what kind of a ECR ratio you need to keep. So how will you go about? So you go to your competitors typically, who would be your competitors or who are your competitors, 5 to 6 people. Say, for example, if I was a software company, on the likes of Wipro, Infosys. So I will see what is Wipro's ECR, what is Infosys ECR, similar companies. I will not compare myself with maybe a Google or, again, in software companies, it is the product related or is it, a service oriented, because depending on that also the wage cost, because the salaries you pay for product leadership are very, very high. But a service you will pay at 60th, 50th, maybe a 65th percentile or a 70th percentile or so. Based on that, you can look into the annual reports into the P&L statements, and you can calculate. It's clearly, they have to mention it there. If it's a listed company, so you will get the revenues, you will get the wage cost, and you can calculate the ECR ratio. Neha, is it clear?
Yes, ma'am.
Yeah.
Ma'am, but
Hmm.
just to understand, if in case the ECR ratio for my competitors is higher
Hmm.
as compared to mine,
Hmm.
what does that indicate?
Good for you, no, but you will
Yes,
still
yes.
have to relocate whether you're paying less salaries, you're not competent, and then you'll have to start looking at data. Hey, is there high attrition, or is it that people are not performing? You might be paying less salaries, or maybe you are actually paying the high salaries to critical positions, and you have automated, so you have reduced your manpower. There could be many
Okay.
things, many variables.
Yes. Yes.
No?
Okay. Yes, ma'am. Got it.
But
Thank you.
if it is
Yes, ma'am.
high, Neha, huh,
Yes.
definitely you need to go back and see why is it high. No?
Yes.
Okay. All right. Okay. Yeah, if any of you can actually share that screen, very interesting. There is something called predictive analytics. You have a worksheet. You have? Vilma, so sorry for. So all of you have this now. Okay. Now you will get into the same breakout rooms with the same participants with the same group. Now let me just show you once. Now these are so these are the questions for you. Good working conditions will lead. So whenever we are using predictive models, we will also kind of have a hypothesis. Good working conditions will lead to high intention to retain. So essentially, what am I wanting to see? Anybody here? All of you have learned. So what are the two variables I want to check now?
Working conditions and
I mean,
retention.
if I'm increasing good working conditions, will they lead to retention? So what do you need to do? Now there is working conditions and retention. Click on that. Okay. Now what will you do? First, establish whether there is correlation. Got it? First, as a group, first establish whether there is correlation. You have to calculate correlation. After that, then you must do regression. And as I said, closer to 1 means, that means increasing, then we will compute by increasing 1 unit of working condition. You can actually compute that way, that so many people will be retained. So you have to calculate regression and then say, yes, depending on what is the R square, then you can say it is true or false. Got it? Okay. Likewise, next, job satisfaction is related to employee performance ratings. That means I'm looking at two sets of data. What are those two sets of data? Satisfaction scores and performance ratings. Now I'm saying higher the satisfaction, that means there will be higher performance. So X is, what is the independent variable here? Job satisfaction. And what is the dependent variable? Performance. If I'm happy, I will perform better. So that's the response. So job satisfaction is your X and employee performance is your Y. Working conditions is your X and retention will be your Y. Behavioral training programs lead to high number of customer orders. Again, you have to say whether it is true or false, depending on your regression measure. High goal alignment will lead to better customer satisfaction. That means if the employees are aligned to the goals, then it will lead to better customer satisfaction. Okay? Yeah. Okay. So who is presenting from this group 1? Or who's presenting from anybody who is prepared quickly to share the screen? Yeah.
With regard to the first one, good working conditions, will it
Yeah.
lead?
Yeah. So can you show the work conditions?
Yeah.
R square, okay. All right. Good. Good work. Can we go to the next one?
Job satisfaction and performance. So
1 to 5.
0.5 is
Negligible. Yeah. I mean, regression is very low.
so
Behavioral trainings, yeah.
behavioral training with the customer.
0.85.
Yeah.
Okay, regression is 0.85, 85%.
Yeah.
So that means,
This
can you just, and is it possible for you to enlarge this?
one, this chart.
No. Your screen.
It's enlarged only. It's in the full.
Okay, no problem. So
Okay.
what I want to tell you all is, now when you see that there's a very good regression, 85%, dependency on what? Behavioral trainings, right? To achieve customer orders. So what does it mean? That you can actually predict, if I increase number of behavioral trainings, you can actually do that. Then how many by one training, how many customer orders can I get? Okay. To that extent, we can compute. That's the power of regression. That's the power of predictive modeling. All right. And so, therefore, when you go to your head HR or managing director and say, hey, I want to do these behavioral trainings because I can actually show you that if I increase by, say, 10 behavioral trainings, you can see what? An outcome of so many customer orders. Huh? Like, for example, I don't know, whoever is here as an HR, hey guys, this is not just for Sivashri and that group. Like, for example, I think I thought Pallavi Kulkarni is an HRBP, whoever is it. So, if you are in the role of an HR business partner and you want to go and ask for more budgets for employee engagement, the first thing you'll say, why we can't, no budgets, we can't give you, right? But if you go with the data saying that, like a Best Buy, if I increase the ESAT score by 0.1%, I can show you that the operating revenue will increase by $100,000. That's what Best Buy, they do a lot of analytics, and they were able to prove that by increasing this ESAT score by 0.1%, they saw their operating revenue income by $100,000 at stores. Okay? Yeah. Carry on, please.
And the next one is
there's one more. Goal alignment and customer satisfaction. Can I see the regression?
1.13.
0.1, or
Yeah.
I can say 0.14. No?
Yeah.
Which is is as good as not there. No?
Yeah.
What is the correlation?
Correlation is 0.6.
Obviously, even the correlation is not there. Okay, another test for you guys. First, whenever you do regression, you should first say, because regression is the strength, whether you can predict the strength. Correlation is only association. So first you should check for correlation. If the correlation is high, then you should do regression. Otherwise, it is pointless. Okay? All right. So good work. Can I see? All of you have done very good work. Now you know how to go about, I'm sure, at least with the statistics. Okay. Let's see the other group quickly.
Yeah, I'm just sharing the screen.
Yeah. So the Shri group can actually take credit of learning and doing the work so accurately and quickly. Great, guys.
Yeah, so this is the first one, work condition and retention. Here we have 0.50 as correlation, so which is moderate one. So good condition will lead to only moderate retention. So I've
No,
put it as,
okay, your regression is 0.50, right?
yeah,
Is it?
yeah,
Oh, no. Sorry. It is correlation, but you need to check the regression.
yeah. It is 0.25.
So obviously it is false because
Yeah.
it's very, 0.25%. So it is false. Okay. Not
Yeah.
even moderate.
Yeah.
Let's go to the next one.
Yeah. This is the job satisfaction one. Here
Correlation is
we
0.50 and regression is 0.25. Again,
Yeah.
false. No?
So this is false. Sorry. This is we have kept it as true because it is saying it
What
is
is
related
regression?
or not. It is high
Ah,
or low. The question in the question it is not there. So that's why we felt it is true.
pardon? Pardon?
So like for in the first question, it says will lead to high intention. So
Hmm,
here
hmm.
it is only asking whether it is related or not.
Job satisfaction is related to employee performance ratings. So what does it actually say is higher the job, if you are in higher the job satisfaction, does it lead to higher performance? So you have say you may feel like that, but what does the data say? That's what we need to see. So just look at your correlation and regression numbers.
This is
For there is a kind of relationship, but
yeah.
when you look at the regression, it your data doesn't really show saying that that you can predict that with the you can say there is some kind of a relationship, but you can't predict that higher the job satisfaction. What where I'm coming from is you can't say if I increase job satisfaction by 1 point, can I say that even the performance is going to increase by so much? That is not possible because 25% only is regression. Okay?
Okay.
Okay. Yeah.
So that one will go as false. Yeah.
False.
Then the third one.
Hmm.
So here correlation is 0.92 and
Very high.
regression is 0.85.
0.85.
So
So obviously that means higher the training. So you can actually compute quantitatively that if I do 10 behavioral trainings, I can actually say that it there'll be an increase of 10% customer orders or 20% customer orders. So that means the training manager can actually tell the business guy, hey, if I do this training program, then your customer orders will increase. Okay?
yeah.
Yeah.
And then
Goal
the last
alignment.
one, yeah, goal alignment. Here it says 0.37 correlation
No correlation at
and
all.
yeah,
Yeah.
no
And this
correlation.
obviously regression is absolute null and void. So
Yeah.
that means there is no, you can't even talk about it because there is no relationship also. Okay.
Yeah. Yeah.
Great. So good, guys. Okay. So good work done by all of you. Yeah. To conclude, what I was wanting to say, any of you who are in the training, department, when you go back, you can actually see what are some of the business challenges if they're not performing, and then you are also giving a lot of training. You can look at your training data and you can look at your performance data, and that's the first thing you can do to see whether there is correlation, whether there is an impact. You can do some predictive modeling through both correlation and regression. Because the idea is anytime you want to take up HR analytics or any new thing, you must first attack that low hanging fruit. What I call it as the immediate business challenges. Okay. So all of you, when you go back, what is the business challenge for me in my role? Okay. So if you are able to contribute to that through this HR analytics, let me tell you, you will not only deliver good results, but also you will get a lot of appreciation.